Right, this is going to be the first of many video recordings that you'll have access to this weekend. First off, I want to say how excited I am that we get this opportunity and how I hope you take advantage of these videos and the resources that you now have at your disposal. All right. In class today on June 18th, we were able to cover Unit 3, Lesson 3.2 and 3.3. So I'm going to make the rest of the videos for Unit 3 that'll be available to you over this weekend. All right, again, all of these videos will get posted on Google Classroom and they'll be available through YouTube links. Okay, the video will be broken down into 3 parts. Part 1 will be I will walk you through the APEX study session. Right, I will walk you through that, give explanations if I can, provide further insight, and do some of the activities with you. All right. Part 2 will be where I go over the study guide or the study sheets. I'll go over those, go through the answers, and walk you through those. And then part 3 will be me going over some of the problems from the concept checks or the check-ups. All right, I'll go through some of those problems. I'll work through them. I'll give explanations. I won't do the full study sheet or the full checkup, okay, because I want to leave some available to you where you still have the answers, but I will walk you through some of them, and then all of the study sheets and all of the checkups, the answer keys are posted on Google Classroom already, so those are at your disposal. All right, and remember, the study sheet nor the checkup is turned in on APEX, but they are super, super valuable resources that I really suggest that you take a look at, work through if you can, and at least have at your disposal when you're taking these various quizzes. All right, so let's get started then. All right, so again, mentioning we already did lesson 3.1. Today in class we covered 3.2 and 3.3. All right, so a couple quick reminders here. All right, as we were going through the lessons, I pointed out the different sessions. So there's 2 quizzes for this one, and I pointed out what the difference is going to be between those. All right, same thing here. You have 3 quizzes for 3.3, and I told you how to find it, right? This one's factoring a difference of squares, factoring perfect square trinomials, and then this one is sum or difference of 2 cubes, right? And again, reminder, this 3.36 journal is extra credit if you would like, okay? It is an extra credit opportunity. It is no longer mandatory, all right? So please make sure you at least complete these 3 quizzes and then can move on if you would like to 3.4 or finish up this journal for some extra credit. All right, so if we go into 3.4 now, right, this whole video is going to focus just on 3.4, and there will be videos for the other lessons within this unit. But 3.4, if we start here with the overview, all right, so again, we should have been working for all of Unit 3 on factoring quadratics, right? We talked about a lot of special cases and we worked through how to do those, okay? But you might be wondering what's the point, right? And again, I keep bringing this up. Quadratics are in a lot of places, but again, in a lot of unknown places where you might not think to look. Again, a lot of times they're used for satellites, they're used for orbit, they're used for planetary things, they're used for astronauts, right? I keep bringing up they're used for throwing baseballs, they're used for, catching baseballs, all that kind of stuff, all right? But for this lesson here, we're going to figure out how to solve quadratic equations, and we're going to write them in the standard form. We're going to apply the zero product rule, and we're going to then move on to solving quadratics that contain perfect square trinomials, and then choose the correct steps for various forms. So if they're kind of mixed up and we don't know necessarily which one. All right, so before we get to the study here, you can notice we have 3 quizzes. So first one is going to be on factoring with the zero product rule, right? So when we go through the study, there will be one whole section on factoring with the zero product rule. This is the quiz that will go along with that. So by all means, you can work on the mini session within this study and then take this quiz and then move on and so forth, right? Whatever you feel is best for you. Okay, the second quiz is on converting quadratics to standard form, right? There's a whole quiz on just converting them to the standard form. And then finally here, quadratics with perfect square trinomials, okay? So that would be the third and final session here in this 3.4 unit for solving quadratic equations. All right, so yes, all 3 of those quizzes are mandatory. You do have to do them. All right, now moving forward. Solving quadratic equations. Okay, so again, remember this soccer problem we talked about, kicking the soccer ball. Who can kick it further, right? They had to dribble, dribble, kick. That is a quadratic. Okay, same thing, dribble, dribble, kick. That is another quadratic, right? And we can figure out who can kick the ball further. All right, and again, the soccer ball is kicked in the shape of a parabola, right? It is a parabola. That is the shape that displays our quadratic equation. Okay, moving forward here. There are numerous skills, okay? There are numerous skills that we introduced today and that you have to be able to do when you're moving forward here. So here's a really good little summary sheet of them, okay? So the first thing we learned was factoring x squared plus bx plus c, right? So if that first constant is a 1, that leading coefficient is a 1, okay? Secondly here, we looked at factoring ax squared plus bx plus c. So if that leading coefficient is not a 1, right? So now we're not just dealing with p and q. We now have to add in an r and an s, okay? And we talked about all of that. And you can refer back to the video lecture from today if you need more information on that. All right. Then we talked about factoring a difference of squares, right? So if I have something like capital A squared minus b squared, okay, I can get this factor out, a plus b multiplied by a minus b, right? And both of those values, a and b, have to be perfect squares, right? And we talked about how to look at that. And then finally here, factoring a perfect square trinomial, right? Factoring a perfect square trinomial. So if it looks like the first following equation, right? If I factor it out and I get a plus b multiplied by a plus b, I can just shorten that and call it a plus b quantity squared. All right, same thing. If I have a slightly different version, I can then get a factor of a minus b multiplied by a minus b, okay? And since I have two of them, I can put them together and say it's a minus b squared. Right, so these are, again, are the four main ones we're going to focus on and continue to work with. All right, so quadratics can be either simplified or already in the standard form, right? Again, a, b, and c are real numbers. Okay, a cannot be 0. That's the only restraint we have on a. Okay, b and c could be 0 though. B and c could absolutely be 0, but you have to have this x squared component in order to be a quadratic equation. All right, so looking at these, there are some that are quadratics and some that are not quadratics. All right, so first off, this one is a quadratic. Okay, so is this second guy here, and so is this third one. All right, they all have x squared, right? This one just is not in the standard form. We would move that 13 to the other side, and we would have a quadratic equation. All right, and then looking at the rest of these, this right-hand side, these are all not quadratics. And the reason that is because we have to have that x squared, and we cannot have the square root of x. We cannot have the square root of x because that's like saying x to the 1/2 power, right? So it can only have an x squared, an x, and a constant, right? So if it has anything else, or if it's missing that x squared, it is not a quadratic. So this doesn't have x squared. This has an additional square root of x, and this one has a 1 or 4 over x cubed, which again, x cubed is not in the quadratic. Okay, moving forward here, the ways to solve a quadratic is pretty simple, all right? You're going to find the factors of the quadratic expression, right? So, again, taking it from that ax squared plus bx plus c, and you're going to figure out the two different factors, right? What two quantities get multiplied together. Then we're going to use this zero product rule, okay? And if you read it here, it's a rule that states if a and b are multiplied together such that it equals 0, then either A is 0, B is 0, or both are 0. All right, and this is really helpful for us because we can actually then solve a quadratic equation, right? So again, showing these steps here. So step 1 is showing how we go to factoring, right? So finding the factors of this quadratic is x minus 4 and x minus 1. All right, we can then do this zero product rule where basically we're saying since this whole thing is equal to 0, either x minus 4 must be 0 or x minus 1 must be 0, or truly both could be. But when we're solving for it, we need to make sure that at least one is not 0. So we have x minus 4 is equal to 0 or x minus 1 is equal to 0. All right, and if we just do some basic algebra here, we carry the 4 to the other side, carry the 1 to the other side, we get x equals 4 or x equals 1, and that's how we solve this quadratic. We solve for the values that x could be equal to when y is equal to 0. All right, solve the resulting equations, right? We just talked about that. So that would be carrying those constants over to the other side, right? Getting x by itself. So again, the zero product rule states that if a times by b equals 0, right? If x times by y equals 0, then either x is 0 or y is 0, okay? So for example, again, we have this quantity here multiplied by this quantity here. That's equal to 0. So either this one is 0 or this one is 0. So then we can actually go in and we can solve that further. All right, so if we're solving the quadratic equation, okay, we are solving the quadratic equation. The first step is to factor, right? So we can factor and then we can check our work here. So again, I'll show you more examples of this, and you are more than welcome to use this factoring tool here, but we would factor out 4x squared minus x minus 3. Okay, and for the sake of time, I'm going to skip to the answer here. Okay, you should have found that the factors are 4x plus 3 and x minus 1. Again, if you want to check my work or check Apex's work, you just FOIL this back out, and you should get the original quadratic here. All right, so then what we do is we have one side equal to 0 and the other side of the factor equal to 0. So 4x plus 3 is equal to 0 and x minus 1 becomes equal to 0. Because if this whole quantity is 0, then it doesn't matter what this quantity is. When we multiply something by 0, it gives you 0. All right, so now looking here, when we would solve this, okay, and that'll be the next thing we do, we'll solve this. So for this first one, you're going to subtract 3 from both sides, and that would give you 4x equals negative 3. Then you've got to get x by itself, so you're going to divide both sides by 4. So this answer here, x equals negative 3/4. Negative 3/4. This one's a little bit simpler here. All we have to do is add 1 to each side, so x equals 1. X equals 1, right? And those are your two solutions to the problem, or those are your 2 zeros to the problem. Those are your 2 zero products. All right. Perfect. All right, negative 3/4 is also equal to negative 0.75, right? Again, that's just solving the quadratic there. All right. After factoring the expression, okay, you can put them into smaller equations. So again, x is equal to negative 0.75 and x is equal to 1. All right, and what you can do is then you can check this, okay, as we always do, check this to make sure that it is true. So if I were to plug in negative 0.75 in for x, I would end up getting an answer that is 3 minus 3, which should give me 0. Same thing over here. If I have a 1, I end up with 4 minus 1 minus 3, which gives me 0. Right, which gives me 0. So that has to be true in order to make sure that your work is correct. Again, that's, in my opinion, that's the easiest way to make sure that you got the right answer before you confirm it, is just plug it back in and see if it works out. Okay, for this one, to solve the quadratic equation, you start by factoring. So what is the factorization of x squared minus 5x plus 6? And we'll do a lot of practice with this. But remember, when you write your answer, you have to show it with the correct parentheses. You have to show it with the correct notation. So for this one here, okay, for this one, since we have our second factor is negative, but our third factor is positive, we know that this has to be 2 negative numbers. So P and Q both have to be negative, right? And it's going to look like this, x minus something, right? When we know that right off the bat. Now, the next thing is what two numbers multiply to give me 6? It's either 1 and 6 or 2 and 3, right? And since this is positive and they both have to be negative, our final answer can be x minus 3 and x minus 2, right? Or x minus 2, x minus 3, they're the same answer, all right? So when I submit, right, that's my sample response, okay? And I put it without spaces. You can put it with spaces, right? But that's what your factor would look like, okay? So then you can see here, you're going to solve for both of these being equal to 0. So x minus 3 becomes equal to 0 and x minus 2 is equal to 0. So I just add 3 to both sides, and that brings that 3 to the other side. So x is equal to 3 and x is equal to 2. So that's my final answer. Again, I want to point out to you, be really, really careful with your signs, okay? And even if you saw x equals 3, you got to make sure that that second one's correct. I don't want you making that mistake on your test, okay? It's a very, very simple one to make. All right. So then again, the solutions are called roots or zeros. All right. And again, we can factor first, right? We factor first and then we solve for x. Okay, we have to factor first, then solve for x. So we're going to skip this and keep moving on because these are going to be like the problems you'll see in the checkups. But this is something you could 1000% see on your quiz and your test. Okay, it's going to ask you to you have to factor first, right? So give me those two factors, and then you've got to solve for x by putting each of those factors equal to 0. All right, so we're going to skip this one for right now for the sake of time. All right, so then here are 4 quadratics from the previous page worked out the way that you would work them out on paper. All right, again, take some time to look through this, okay? I'll walk you through quickly, but if this isn't really evident to you right off the bat, it's not a huge deal. Take some time to digest what this is saying. Okay, so for this first one here, right, we did this x minus 3 and x minus 2. So we got x equals 3 and x equals 2. Okay, for that second example here, there is no middle term, right? So this is more like what we just learned. Okay, I've got a squared minus capital B squared, right? Because I've got two perfect squares. All right, my first perfect square is going to be an x, and my second one is going to be 5, right? Because 5 squared gives me 25. So I automatically know I have to have a plus and a minus because I have no middle term there. So this gets me x plus 5 and x minus 5. Therefore, when I solve, I have x is equal to negative 5 and x is equal to positive 5 because I've got to get x by itself. All right. Again, looking at this one, this is one where that first value, that a value is not equal to 1, okay? Same thing though, you're going to factor it out like normal. Again, if you're stuck with the factoring, you can always check it out through foiling, okay? You can check it out through foiling, but r times by s had to give us 2, right? And there was only 2 combinations. It's either 1 and 2 or 2 and 1, right? And then to equal 1 here, to equal 1, 2 numbers multiplied together to give you 1. It's going to be 1 and 1, right? So that one shouldn't have been too terribly difficult, hopefully. All right, and again, since this is positive but this is negative, that means they both have to be negatives. All right, so when we carry that through and we solve, we end up getting a positive 1/2 and a positive 1. All right, final example here. Okay, final example here. Okay, so we've got 4x squared plus 4x minus 15, okay? So there's only 2 combinations that could give us 4x squared. It's either 4x and 1x or it's 2x and 2x, all right? And we work through, if we work through the problem here, okay, we end up with our x values here. Okay, again, it is very repetitive. It's the same thing every time. The difficult part in this process is getting to the factoring. So hopefully by now you're starting to feel more confident and you can rock and roll with these factors. All right, so reading support, okay, the soccer problem, right? Again, you can end up solving, okay, you can end up solving the factors to figure out who kicked the soccer ball farther, right? Again, I'm not going to work through this here, but you could, right? This is what you would be able to do in a real world situation. Okay, the ball went some distance high, some distance far. We're not really sure, but we know the shape, right? And we can figure out who's going to kick that ball farther. Okay, so this is the last couple of slides here for the zero product rule, okay? So blank can solve a quadratic equation. Factoring can help solve a quadratic equation, right? Getting those to those smaller factors. So taking it from ax squared plus bx plus c to quantity r x plus or minus p times by sx plus or minus q, right? Factoring those can really, really help. Okay, so then again, to solve a quadratic equation, to solve and to get those x values, you got to factor, you got to use the zero product rule to set up those smaller equations, right? Setting each factor equal to 0, and then solving the resulting equation. Okay, Again, we're going to skip these for the sake of time here. You can definitely work through them and see if you're on the right track here. Now, here's where I'm going to leave you to work on these yourself, okay? My personal suggestion, again, once you watch this video, at least go through the notes quickly, come to this, and try these sample quiz questions here, okay? You're going to get immediate feedback. You're going to know if you're doing this right. You're going to feel more confident going into your quiz, okay? But these types of questions here, these types of questions, this is your first quiz. This is 100% your first quiz, all right? So from slide 1 to 14, this is your first quiz, all right? Now, moving forward here, this is going to be the content for your second quiz. This is going to be the content for your second quiz. So equations not in standard form, right? So we have multiple ways of putting it in standard form, okay? And here are 4 of the ways that we've really talked about, okay? So combining like terms would put it in standard form, all right? Making sure that you multiply everything out, combining like terms, okay? Multiply out, combine like terms. Same thing. If there's any variables or if there's any constants on both sides of the equations, make sure you put them all on one side, right? So moving the 8 to the other side, or moving the negative 7x squared plus 8x to the other side, right? It's all about getting it in that ax squared plus bx plus c form. All right. So here are 4 more examples of quadratic equations that are not in standard form. All right. So if we go here, this is that first example, I believe. Okay. So all you're going to do is subtract 5. Okay. You're going to subtract 5 from both sides, combine those like terms, and you're going to get standard form. Okay. For this one's easy. You just combine like terms. Okay. So you combine like terms, and now we have it in that ax squared plus bx plus c form. All right, this one here, you need to subtract negative 2x squared plus 5x from both sides, right? So that would be what that looks like, okay? That would be what that looks like, all right? And then what you're going to do here for this final one, you've got x plus 3 squared plus 4x. So you're going to distribute out, you're going to multiply. Okay, so expand that. You're going to collect your like terms, and then you should end up with this final product here, looking in that ax squared plus bx plus c format. All right, moving forward here. Okay, moving forward. After putting the quadratic in standard form, you can often solve it. Okay, so right, just exactly what we talked about. You put it in standard form, you factor it, and you solve by setting each of those equal to 0. All right, so again, the key in all of this is getting it to that standard form, okay? We're going to keep harping on that, getting it in standard form, then you can do a lot of things with it like solve, all right? So to solve, x squared plus 9x might equals negative 10. First, put it in standard form. You got to put it in standard form. Once we do that, then we can factor, then we can use the 0 product rule, all right? So again, how do you solve a quadratic equation that's not in standard form? Easy. Put it in the standard form, factor it, then use the 0 product rule, and then solve the resulting equations. Okay, so practice here. Okay, this one is one that you are able to do through Apex, so please make sure that you take some time to do it. Okay, but this is talking about how do we get it from not standard form to standard form. So for this one here, okay, you can see everything's on the left side of the equation. Okay, all we've got to do is we've got to combine like terms. So the like terms is the negative 15x and the plus 14x. So I'm going to end up with a negative x squared plus x plus 12. All right. To do another one here, right, I've got x squared plus 8x plus 12 equals 5. So I've got to bring 5 to the other side. All right. I have to bring 5 to the other side, so 12 minus 5 is 7. So I'm left with x squared plus 8x plus 7 equals 0. Okay? And for anything larger than that, right, same thing. You're just going to get everything on one side. This one, you're going to combine like terms. This one, you're going to get everything on one side. Okay, this is the only one that might take a little bit of work here. You've got to actually carry out and execute what x minus 3 times x minus 3 would be. Okay, so you'd carry that out, then you'd combine like terms, and you'd simplify from there. All right. Okay, so again, check your understanding. This is something that, again, I'm going to suggest that you do on your own here, okay? These are going to be questions that you're going to see on your quiz here, right? And this brings us to, this is your second quiz, right? Everything we just covered, right? Putting things in standard form and solving from standard form. That's going to be quiz number 2 here. Okay, so hopefully it's not too difficult. Standard form here, right? You're going to move 48 to the other side. Standard form here, you're going to execute out, right? So distribute that 3 out. Then you're going to move everything to the other side. You need it in the ax squared plus bx plus c equals 0 form. Okay, same thing here. Except now, it says you're looking for the solutions to the equation, okay? So first off, we've got to get this in standard form. That's like rule number 1. Get it in standard form. Once it's in standard form, then we factor. Once we factor, we can use that zero product rule. So putting both of those factors equal to 0. All right. And then number 4 here, okay? Same thing. You've got to get it in standard form first. So carry that 3 through both of those quantities. Right? Get everything on one side. It doesn't matter if it's on the left or on the right. Dealer's choice there, okay? But regardless, you're going to get everything on one side. Once you do that, then you are going to factor. Okay, so then you are going to factor. You should get 2 quantities, all right? You should get x minus something or x plus something and then a whole nother one, right? You're going to put both of those factors equal to 0 and then you're going to solve from there, okay? So again, that's putting it all together. And these questions are, again, what's going to be on quiz 2 there. Okay, and then finally, the last little section in this 3.4 study is not changing an equation to standard form. All right, so there are some things that might not get changed to standard form. It might be easier to solve, or it might make it impossible to solve if we change it to the standard form. All right, so for example, the standard form is down here, and this is the not standard form. But if we actually look at this standard form, we can't solve this quadratic. Okay, we cannot solve this quadratic. There is nothing that will give us -4 that will also give us plus 2x when we do it. Right, there's nothing here. Okay, and it says if you have any doubts, you can try it for yourself. All right, but if we look here, we can actually solve this top one here, and we'll talk about why or how that might work. Okay, so x squared plus 2x plus 1 by itself, that left side, that is a perfect square. And otherwise, in other words, sorry, it has 2 factors that are identical, right? So this ends up being x plus 1 times by x plus 1, right? X plus 1 times x plus 1, okay? So it's actually easier to factor it if we leave the right-hand side as equal to 5, right? It's not always, but if we have perfect squares on the left-hand side, why not? It makes it easier for us, right? So to solve for a perfect square trinomial, okay, you would factor the perfect square, then we would take the square root of both sides, simplify the equation to make 2 equations, and then solve both of the simplified equations. All right, I know that was quick, so let's look at what that actually looks like. Okay, step 1 says factor the perfect square trinomial. So factor, right? As I told you, you're going to have x plus 1 multiplied by x plus 1, or another way of saying that is x plus 1 squared, okay? Then we're going to take the square root, because by taking the square root, we can get rid of that squared right there. However, when we take the square root, we have to take the square root of both sides of the equation. All right, we have to take both sides of the equation. All right, and when we're doing this, we change the right-hand side. It's going to be plus and minus. Okay, so we're going to have a positive version and a negative version. Okay, because if we were going in the opposite direction, right, if we squared a positive 2, it's going to give us 4. Same thing, if we squared a negative 2, it's going to give us a 4. So we don't know if this 5 came from a negative version or a positive version of that number. So we've got to give both potential options. So what that looks like here is we've squared this. So now if I annotate this, oh, it won't let me annotate. Apologies there. All right, wait, hold on. Here we go. All right. So what this is going to look like is x plus 1 is equal to plus or minus square root of 5. Right? Plus or minus the square root of 5. So what we do here is we have the positive version on one side and the negative version on the other. So that's how we get both of our equations. That's how we get both of our equations there, okay? So then when we keep going through, okay, we got to have two solutions for our x value. So we're going to solve for this one, right? We bring the 1 to the other side and we just call it the end of the day, right? X is equal to -1 plus the square root of 5. Done. Don't simplify any further than that. Same thing on this side, except now we're going to have a negative square root of 5 minus 1. Okay, don't simplify any further than that. All right, and that's the end of that one. Okay, so again, we factor the perfect square. So we factor the left-hand side if it's a perfect square. Okay, then we take the square root of both sides. And when we take the square root of a constant, we have to have the positive version and the negative version. And that's fine with us because that's how we get our positive answer and our negative answer. Okay, then we just solve from there. Okay, so again, steps for solving a perfect square trinomial. Okay, if we have x squared minus 12x plus 36 equals 8. Okay, what that does is we can factor the left-hand side. So this quantity here is actually a perfect square trinomial, okay? Because x squared is a perfect square, so is 36. That's 6 squared. And then this number in the middle is a negative. So that means that we have -6 squared. So what that looks like here, if I drag this over, it ends up with x minus 6 squared equals 8, right? X minus 6 quantity squared equals 8. Next, we take the square root of both sides, okay? So when we take the square root of both sides, we get rid of that squared right there. So I have x equals 6 is equal to plus or minus square root of 8. And again, it's positive and negative because we don't know which option it came from. So we do both. We set up two equations. So either x minus 6 is equal to positive square root of 8 or x minus 6 is equal to negative square root of 8. And we solve for both of those equations. And once we solve for that, we get square root of 8 plus 6 or negative square root of 8 plus 6. All right, so there's our summary right there. Okay. So here's a couple more examples here. Okay, and I'll go through these quickly because you can click on them yourself here. But again, realizing the left-hand side is a perfect square trinomial, so we don't mess with it, right? We factor, we take the square root of both sides, we set up our two equations, and we solve, okay? Factor our perfect square trinomial, take the square root of both sides, make two equations, solve for both those equations. Same thing. Perfect square trinomial, we factor, square root, set up two equations, and solve for both. And finally, the last one there. Okay, factor, square root, set up two equations, and then solve. All right, and again, this one is just a problem. Okay, so this one is a problem, and I don't want you to get confused when you get to tests. Okay, this is all about just finding the variables that they tell you. Okay, so for example here, projectile motion is launched an object. Okay, and here's the equation. Is represented by the following formula. In the first term is represented by the acceleration due to gravity. Okay, so this term here is acceleration due to gravity. V is the variable used for the initial velocity. H is for the initial height. Okay, H is for the initial height. All right, so how to use this information to improve your water balloon fights. Okay, what you can do is you can plug in once it tells you different informations, right? So originally it said that we had certain variables equal to certain things. So now it's saying, great, I'm filling in those things for you. So right here it says the balloon is launched in the air at 24 feet per second. Okay, that's how fast it's going. So that gets plugged in here for our velocity or for our speed. Okay, so our equation starts to look like -t squared plus 24. So it's either option 1 or option 2, and it's 24t. Okay, so it's clearly not this next one here. And then H0 said it was the initial height. It was the initial height. Well, we have an empty pool. So we're not at ground level. We're 9 feet below ground level. So that makes it a -9, right? So that would make this second equation our answer, okay? And then moving forward with the rest of this problem here, if you want to keep going, okay, you're just going to do the exact same thing. You're going to factor, right? Once you factor, then you can set both of them equal to 0 and you can solve for the final answer here. Okay, so confirming, this is the last couple of things here. So confirming for perfect square trinomials, all right, you should be able to now solve quadratic equations. You can put them in standard form. You can solve them if they're perfect square trinomials, right? Knowing when and when not to have to go back to that standard form. So key here, it blank helps to leave the equation in non-standard form before solving it. It sometimes helps, right? Pretty much if it is a perfect square trinomial, don't touch it. Leave it the way that it is. But if it's not and you're not sure, you can always then put it in that standard form and solve from there. Okay, so how do you solve a quadratic equation that is not in standard form and contains a perfect square trinomial? Well, you factor the perfect square trinomial. You leave everything else where it is and you focus on the perfect square. Okay, then you take the square root of both sides. Then you simplify the equation to make two equations, right? You have that positive version and the negative version, and then you solve for both of them. Okay, same thing here. Again, these are quadratics with perfect squares. So this one is a little bit more involved, and I'll let you take your time and work through this. You guys can do this one. It is a click and match up, okay? But right here, you're solving for things with perfect square trinomials. So again, this is about reading context clues. If it has a perfect square trinomial, remember we said don't touch anything else. Don't touch anything else. Right? So you wouldn't have to, this first example here, this is a perfect square trinomial. It's already done for you, right? So the next step that we would need to do is take the square root of both sides. Okay, so if I take the square root of the left side, I'm left with x equals 3. And then the square root of the right side is equal to the square root of 15. Okay? So then if I set up a positive version and a negative version, I'm going to, regardless, I'm still going to add 3 to both sides. So that's how I get my final answer there. Okay, and my trick for doing this was there was only one option in all of these that had the square root of 15. Okay, so I immediately knew that that was going to be my answer. I knew that was going to be my answer. All right, same thing here, right? If I have 9 and 11, I know that the square root of 11 minus 9 is going to be my answer. It's the only one with the square root of 11. Okay, so taking the time to just realize some patterns there can be really helpful and a time saver for you. All right, and again, finally, we have now come to our last little check your understanding, and this is going to be, again, an example of what the last quiz in this unit is going to look like, okay? It's going to be an example of what the last quiz in this unit is going to look like. So, again, can you square both sides, right? Great, hopefully you can. So then you're going to have a positive version and a negative version. All right, and these answers, it's only got one potential option here, okay? It's not making you give both. All right, so I would have x minus 7 equals the square root of 11. I have to have square root of 11, okay? So immediately it's either A or C. And since I have x minus 7 equals square root of 11, I would then have to add 7 to both sides. So my final answer here is going to be letter A, right? That's how you can walk through this if you don't want to actually write it out. But again, if you're not comfortable with that or you don't have your skills honed, that's totally fine. Take some time, write it down. That's why I love this online program, because you have all the time in the world that you feel necessary to work on this stuff. Okay? Again, here's another example of what that might look like. It just gets a little bit more involved if you have to then divide by 2 to get x by itself. Okay, for this one here, it's backed up all the way to the beginning, right? So you've got to factor this perfect square here. This is a perfect square on the left side, so you've got to factor that perfect square. Then you're going to take the square root of it, set up your two equations, and solve from there. All right. And then, which of the following answers is a solution? Okay, so same thing, perfect square. I know it doesn't look comfortable, but 16 is a perfect square, and so is 1. Right? So that's a perfect square. You set up your factor, okay? You take your square root and you solve from there once you've got your two different equations. All right, so now we are on to part 2 of this, right? So if you feel confident with what you just watched and you don't want to watch the rest of this, by all means, but we're going to go through the study guide and then we're going to go through some worked problems on that concept check here. All right, so first off, 3.4 study, right? 3.4 study. So when I have the answers here, it'll tell you what pages that you can go back and look. So if you don't understand something or something doesn't make sense, go back to that page, right? So page 1 is all the way back there, but right, it'll walk you through and say, okay, page 1. Or if you've got a question and it's on page 18, maybe it's down there, right? Page 20 to 23. There we go, that's a better example. Okay, so 20 to 23, that's here. 1, 2, 3, right? It's talking all about there. So again, please take advantage of that. If this isn't making sense to you, go back and look at the pages. All right, but first off here, a quadratic is an equation that has or could be simplified to have the standard form ax squared plus bx plus c, right? Again, the key there is it has to have that x squared. Cannot have more than x squared, and it has to have x squared, and go on from there. All right. The zero product rule, showing you in 3 different ways, in words and variables and in polynomial examples, okay? So first off, basically it's saying in words, if 2 things multiplied together equals 0, at least one of them has to equal 0. Or if I have a times by b and equals 0, then either a is 0, b is 0, or both a and b are 0. All right, and then the last one here, if x plus 3 multiplied by x minus 1 is equal to 0, then x plus 3 is equal to 0, or x minus 1 is equal to 0. Or, again, both of them are. But this right here is really how we set it up, because then once we know these 2 separate equations, we just solve there using basic algebra skills. Okay? So again, this is super helpful to have with you on your quiz, okay? Super, 100% helpful. It walks you through if you get stuck during your quiz, how to solve a quadratic equation. All right, so step 1, factor the polynomial, right? So give me those 2 factors based on all that stuff we've worked on for the last few days here. Okay, then can you write the factor as an equation is equal to 0? Basically, take this first one, set it equal to 0. Take the second one, set it equal to 0. Then you're going to solve each of them. Okay, so solve each of them. The solutions are the solutions to the quadratic equation, all right? These are your solutions. X is equal to this and x is equal to that, all right? And then you go back through and check, use substitution. So you plug back in for x and x squared and x, your 2 different solutions, and you should get out that 0 equals 0, and if it doesn't, that means you messed up somewhere along the way. Okay, number 4 here. Not in standard form, putting it in standard form. So all we did was we moved 5 to the other side by doing subtraction. Okay, for this one, we had to move the entire minus 2x squared plus 5x to the other side of the equation. All right, so we moved everything to one side. For this one here, we had to multiply out x plus 3 times x plus 3. Then we had to combine like terms, so we ended up with an x squared plus 10x plus 9 equals 0. All right. Okay, now this one here, if the quadratic equation is a perfect square trinomial that is not equal to 0, don't touch it. Don't put it in standard form, okay? Because what we can do here is we can factor the perfect square trinomial. So take this one here, make it x plus 2 is equal to 6, right? Then we can take the root of both sides, right? Take the root of both sides, set up a positive equation and a negative equation. And then we can solve for both of these equations. All right, and again, we leave it as square root of 6 minus 2 and negative square root of 6 minus 2. Don't go any further than that. All right, and that is, again, that is our study sheet that summarizes basically all of 3.4 there. And next, we're going to move on to the checkup here, okay? The checkup. But before I do that, again, highlighting, you've got 3 quizzes, 1, 2, 3, and that's broken up within this 3.4 study. So please make sure you're paying attention to the labels and paying attention to the notes that you need for that, okay? But we're going to move forward here with this 3.42 checkup, and we'll work through a couple problems. But we are only working through a couple of these, all right? We're going to work through a couple of these. All of the answers, all right, the entire answer key is posted on Google Classroom already. So if I don't do the problem that you think, or you've already done these, or you want to check yourself, go ahead, do them, and then you can check against the answers either on Apex or on Google Classroom here. It is only 1 page, so I would suggest trying at least 1 or 2 in each of these sections.